This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today's topic is Introduction to Synthetic Materials, Basic Principles of Mechanics in Mechanics of Solids. Here, Introduction to Mechanics of Solids. Whenever a load is attached to a thin sheet, a thin wire, hanging freely from the support and subjected to load acting at its end position, it elongates in downward directions. But depending on the type of the materials, the elongations distances may be this small. Sometimes it is also negligible for the certain solids. The amount of which the wire elongates depends upon the amount of load that is attached to the end of the wire, as well as the nature of the materials and cross-sectional area of the wire materials. But when it is elongating, the internal forces which are developed by the molecules, which is always oppose the deformation of the wire. When both are equal, that is the resistance offered by the molecules and the load attached, when both are equal in magnitude and acting in opposite directions, the elongation stops. Otherwise, if the resistance offered to the molecule is if it is very less, the elongation is continuously produced until it fail takes place. Here, the resistance offered by the material of the body to oppose the deformations when the external forces are acting on it is called strength of materials. The overview of the subject is the mechanics of solids deals with the deformation of solids, requires the basic knowledge of principles of engineering mechanics as a prerequisite. Afterwards, after completion of this course, it also becomes a prerequisite for the advanced courses in aeronautical engineering, such as aircraft structures and analysis of aircraft structures, and also finite element metal later. This course introduces the concept of simple stresses and strains, principal stresses and strains, and also focuses analysis of members subjected to axial, bending, and torsional loads. In a nutshell, the course aims at developing the skills to solve engineering problems on synthetic materials. Eventually, through this course content, engineers can analyze the response of the various structural members under different loading conditions and design the same, satisfying the safety and the serviceability conditions when it is made as a product or part of the mission. If the course title is Mechanics of Solids, as per the IARE UG 20 regulations, with the course code AAEC01 for BTech third semesters, the course type is core. The main course objectives are the concepts of mechanics of deformable solids and their constituent relations, including stress-strain relations, thermal stresses, strains, resilience produced under various loading conditions for determining the strength of aircraft structures as well as the mission members. The second course objective is the methods of determining shear force bending moment, twisting moment, flexural stresses, shear stresses, deflection of beams subjected to various loading and boundary conditions for identifying the shape, size and the materials required in designing aircraft components depending on their operations. Third, the methods of identify the principal planes, maximum, normal and shear stresses, shear strength produced under the loads, and power transmitter through the shafts for analyzing aircraft propulsion system. For this course, identified 6 course outcomes. They are: the first one is understand the concepts of stress-strain relations, material construction relationship, and strain energy for solving the stresses and strain induced in the body under various loading conditions. Course outcome 2: illustrate the shear force and bending moments in beams for analyzing structural behavior based on different loading conditions. CO3: analyze the effects of various loading conditions on symmetric and unsymmetric beams for determining flexural stresses. Course outcome 4: illustrate the effects of various loading conditions on symmetric and unsymmetric beams for determining the shear stresses. 5. Make use of different methods such as for finding slope and deflections under different loading conditions. Course outcome 6. Utilize the concept of power transmission through shafts and stresses induced on inclined planes using graphical and analytical method for further comprehension of aircraft propulsions and structures. Okay, these are the 6 COs identified for these subjects. And Bloom's knowledge are cognitive level. For first one, it is understand. Second, apply. Third, CO also apply. Fourth, apply. Fifth, apply. And sixth also apply. The syllabus for the mechanics of solids is designed in 5 modules. The first module consists of the main content is simple stresses and strains. The second, shear force and bending moment diagrams. Third one, flexural and shear stresses. Fourth, deflection of beams. Fifth, torsion of circular shafts, principal stresses and strains. The textbooks for the mechanics of solids are P.C. Poonmia, Mechanics of Materials, Lakshmi Publications. The second book is T.H.G. Nexon, Aircraft Structures for engineering students. Better Worth Animal Limited, 5th edition 2012. Third, Gere Temishenko, Mechanics of Materials, McGraw Shields, 3rd editions. These are the 3 textbooks prescribed for the mechanics of solids. While analyzing the forces, some useful data is also here presented. This system is units now being used in many countries, including in India. In this system of units, the fundamental units are in meter, that is the length is mentioned in meters, and mass in kilograms, and time in seconds, that is in MKS units. The density or the mass density, it is expressed in terms of kg per meter cube. that is mass per volume. The force, it is the product of mass and accelerations. It is expressed as in newtons. It is represented as capital N. The pressure, the force per unit area, that is Newton per meter square. But sometimes it is also expressed in terms of Pascal. 1 Pascal is equal to 1 Newton per meter square. The stress force per, the resisting force per unit area, it is also expressed in terms of Pascal only. 1 Pascal is equal to 1 Newton per meter square. The work done, it is represented as a force into, it is the product of force into distance. It is expressed in joules. Power, it is the rate of doing the work, that is joules per second or work done by per second. It is expressed in watts. So the importance of mechanics of solids, here we are discussing by using the product cycle in a computerized environment. Here for manufacturing any new product in the industries is broadly classified into two categories: computer aided designing and computer aided manufacturing. Sometimes it's also called computer aided drafting. Here in designing a product, first we required what is the need of that product. If it is available in the market, do the literature survey. What are the just merits and demerits are there? For newly product, what are the merits we have to incorporate it into the design, including simplify the designs, decreasing the cost, increasing the life of the product. Okay, after identify the need of the product, what is the concept is required, how it is a functioning and everything is identified. Afterwards, by using manual or by using computer, just design the product. After designing, here by using geometrical modeling, so design the sub product. After designing, whether it is withstand the forces which are acting on it, when it is put in operations, it can be analyzed by using simulation softwares. And if it is perfect, it is there now, then computer aided drafting is required. That is the final drawing, it is there. Okay, this entire part comes under computer aided drafting. That is what is the need of the product and how it is developed, what is the final drawing, this including the dimensions and the materials we have to keep it. Okay, in analyzing, that is in simulations now, what are the forces that are developed or transformed when the product is put into operations, whether it is withstand or not, that can be done by selecting sometimes proper materials as well as the cross sections as well as the length of the product. That is the physical dimensions of the product. That is the material properties also important. Which type of materials that is required and what is the area of the cross sections. That is the physical dimensions of the object. So here the material properties plays a key role for withstand the forces which are developed or which are required to transformed and the power transmission is taking place without having any deformations. But in universe, every material deforms. The deformation sometimes it is negligible when comparing with the physical dimension of this object. Moreover, sometimes it will not affect the performance of the product. In that case, the deformation is treated as negligible. Here we have to consider the materials which will not having the deformations as well as they withstand the forces without having any deformations or fractures when it is put in operations. That is the most important here for the selection of the materials or for studying the mechanics of solid subjects. After designing is over, okay, the material procurement is required. The computed CNC part program is required. Identify the suitable machines and scheduling is required. And the computed work standards identified. After that, that machining process is taking place. If it is a perfect, after that inspection, then quality control it is there now. It is now marketing just to look forward. What is the feedback that is obtained from the stakeholders? Depending on that feedback, again sometimes if it is required, again the designs has to change now. This process here it is called computer aided manufacturing. So the combination of computer aided drafting and computer aided manufacturing, it is treated as a computer integrated manufacturing. It is also called CIE also sometimes. So the important of mechanics of solid is select the proper materials to withstand the forces when the product is put it in operations. So the selection of material is most important to increase the life of the product. Here the properties of the materials are here first the practical application of engineering materials in design and manufacturing depending on knowledge of the material properties under wide range conditions. So without knowing the knowledge of the material properties, for the design engineering it is difficult to select the proper materials for the given product. The term product property, it may be the qualitative or it may be the quantitative measure of the response of the material to externally imposed conditions like forces as well as the temperature. The classification of the materials are divided as mechanical properties, thermal properties, optical properties, physical properties, magnetic properties, chemical and electrical properties. Okay, the important of knowledge of material properties. The engineer must have the intimate knowledge of the properties and behavior of the materials. That is the characterization of the material that he intends to use as a product. While designing a product, need to select materials to create the product. For the selection of materials, the designers must assess the properties of each material to ensure that the selected materials is appropriate for manufacturing the desired product. For understanding the properties of the materials is highly essential because without these informations and the knowledge, the design of manufacturing process may be an expensive and complex task. Okay, the right choice of the materials also decrease the expense of the product because you can identify whether it is manufactured by using which method. Mechanical properties. The mechanical properties are the properties of the materials that it determines its behavior under the applied forces are called mechanical properties. These are usually related to the elastic and plastic behavior of the materials. That is, when a material is subjected to the load, the deformation is taking place. The deformation is means here changing the dimensions of the objects. Okay, depending on type of the load that is active. Here I am example. I am taking this as one product now. If I apply the forces, this force is treated as a tensile force. The length of the object is increases. At the same time, so the cross section area of the object is decreases. So here, after releasing these forces, if the object is comes to its original shape, that property of the material is known as elastic properties. But sometimes, if it is deformed behind the elastic limit, after removing the forces, it will not return to its original shape. That property of the material here called plastic. Hence, here the properties are studied which are related to the elastic as well as the plastic behavior of the materials. These properties generally express as the function of the stress and strain, etc. Hence, the knowledge of mechanical properties provide the basis for the predicting the behavior of the materials under different loading conditions. The mechanical properties of the materials which are associated with the ability of the material to resist the mechanical forces and the load when they are applied. These mechanical properties are classified as one is elasticity, second one is strength, third stiffness, fourth plasticity, fifth ductility, sixth weldability, seventh malleability, eighth hardness, ninth brittleness, 10th creep, 11th formability, 12th toughness, 13th resilience, 15th fatigue, castability, thermal conductivity, electrical conductivity, and so on. These are all the properties in this case. Some are there now, which are belongs to mechanical properties, some are thermal properties, and electrical properties, and so on are there now. Okay, if we know the properties of each materials, we can select the right materials for the product, because of which the machinability, that is the producing the product, becomes less expensive, and also the life of the incubator also can be increased. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.